Yes, great discussion so far. So I'm not going to take very long, and then we'll take a quick break, and then we'll go out and you can see the trial, and we have some evaluation sheets for you to evaluate the pots out there. So that'd help us out too. See them in overwintering, which obviously I don't think that there's been any overwintering studies with the containers. Okay, and yeah, okay, so we don't have a very big trial, but okay. So I'm doing the nursery landscape sustainability part, and as an extension specialist in nursery and landscape, my interest is in how this project fits in with sustainable landscaping. Because as Mary mentions, there's a lot of interest in sustainability, as James gave the definition of sustainability, but we're interested in how this fits in landscape sustainability. So there's a variety of definitions for landscape sustainability, starting with attractive environment, but balance with the local climate, and minimal resource inputs, as James was mentioning in his definition, and that's the definition of sustainable landscaping from Colorado State University. Another definition is sustainable landscaping is a stable and productive ecosystem that conserves the physical and biological processes. So, of course, this project is helping in that kind of thing by conserving our physical and biological resources. And then, regardless of what definition you're looking at for sustainable landscaping, there is really about 10 to 12 concepts depending upon who you're talking to in this whole thing. And so there's soil management, water use, all these different things. And this is the one that we're looking at as a concept here within this overall arching thing of sustainable landscaping, of reduction of the waste stream, and especially plastic. So some of these sustainable landscaping things take a lot longer than others, and I think that we probably are into one that is a long-term process here. But even things like soil management and composting, a lot of people think that that's a very quick process, but it takes actually about 10 years to get to a stabilized organic matter when you start into the composting process. And most people aren't realizing that this is a very long-term involved thing with most of these sustainable practices. And even in that process, only about 10 to 20% of it actually becomes stable organic matter. And also that you have to add a lot of material in order to have an impact. And this is the same sort of thing that we're looking at with this bioplastics thing. Some of them are short-term things, like reduction of water use is obviously something that you can obtain quite quickly, even with just distribution uniformity test and fixing the system. But whether you're talking about the different definitions or the concepts, really there's three main goals to sustainability: environmental health, economic profitability, and social equity. Those are the three components of any sustainable program. And certainly we are dealing with all three with the bioplastics. In terms of their impact on sustainability, we have 540 million tons of plastic being used in agriculture, which with the pots representing about 59% of that. So when we say that it's not as big an issue as it is with bottles or with bags, that's probably true. But for our industry, it is a huge issue. And if we're practicing this sustainable landscaping, which is what everybody is pushing towards in the industry, this is where we have to go, because this is one of our major issues. We are representing, with this 59% or this 500 tons, 8% of the world's petroleum production, 4% in the production of these plastics, and 4% in the disposal of them. And as was mentioned, this is about 2% of the waste stream by weight, and 20% by volume of our waste stream in the United States is plastics. So we've made some gains in this reduction of the waste stream in terms of recycling the poly off of the houses. This is up in Lake County. These are pictures by Randy Zondag back there in the corner. That's been driving discussion, where they're picking up all these plastics. The company comes in and puts it all into these big things. And then in terms of the overall recycling of our material, we are lagging way behind versus other things that we're recycling. We're doing, sort of getting to do pretty decent job on paper, metals, things like that. But plastics, we're way behind with only 4% as a national group in all plastic recycling. Reduction of the waste stream, we're also making great gains in terms of collecting all the landscape waste material, the debris. We're making good gains in reusing these materials in the landscaping. This is plastic decking, using different products that we're recycling. This is recycled asphalt being used as pavers at the courthouse downtown in Columbus. But again, in terms of recycling pots in particular, we are well below the average. Mary's already mentioned the Missouri Botanical Garden, which is the most successful recycling program in the United States in the nursery landscape industry. And in 2007, they had collected a total of 300 tons in a 10-year period. The interesting thing there was that only represented 2% of the plastic that they had actually used, they themselves. So really they made very little dent, and it's sort of like the composting. You make very little dent until you actually are getting into these massive amounts of numbers to have an impact on these things. Now, there's a variety of reasons why recycling, isn't working, including the fact that, as Mary mentions, there's nowhere really to do these programs, and we have to make a better effort at that. Reusing, there's a variety of reasons why we are not reusing these pots in the nursery industry. Most nurseries do not have the space required to store, just like you're saying, Mary. They prefer the new containers. If they're going to use them, they have to wash the pots. And in that case, they need to convert a truck trailer into a steam generator to put the material into for days. They don't have the space for that. And only small and specialized nurseries are actually able to have a profit margin with doing any of those kinds of things. So there's some big issues with the reuse of these materials. So really the option that we have is reduce. Recycle is making some starts. Reuse is going to be almost pretty difficult to do. And reduce. And so that's where the bioplastics project is fitting in reducing all of this plastics that we're using. So we will go out and look at this trial out here in the container area. This was our study for 2003. We had 2 plants in there, which you'll have a bit of a chance to evaluate. Of course, they're mostly dormant right now. A sedum and a forsythia in our trial. We initiated the trial on June 30th. There's 8 pot types out there, including a control, which is a high-density polyethylene pot. And it's in our retractable roof greenhouse, which we'll show you when we get out there. And the pots were put onto a ground fabric to prevent rooting out into the gravel that's underneath there. And we did that also because we are leaving the pots for a length of time. And some of them, you will notice, have already started to root into the fabric, but they're not rooting into the extent that we can't get them up. And then we did a rating of these pots. We did a rating on the pot, and we did a rating on the plant. That's what I'll be asking you to do on a scale of 0 to 10, with anything that is equal to or greater than 7 being commercially acceptable for both the pot rating and for the plant rating. And so 10 would be a perfect score. There's absolutely nothing that you would find bad about the plant. In our trial results so far, and this is a evaluation over 3 months, so we did an evaluation in August, September, and October, and we had pots that were the Morel and Lignin, Morel, the polyamide and PLA, recycled PLA, the high density polyethylene, which I mentioned, which is the Czech, the paper fiber pot with 1 coat of polyurethane, with a 2 coat, and with no coat. As you can see, in terms of the preference of the plant for the pot, how the pot was standing up depending upon what species was in it, really the Morel and the high density pot have both got perfect scores, but there's no statistical difference between any of those pots. And also still commercially acceptable at 3 months after is the 2-coat polyurethane. In terms of the sedum, alone over the course of the dates, looking at date 3 here, the ones that are still commercially acceptable or for the sedum are the Morel, the polyamide PLA, and those are really the 2 main ones, and then of course compared to the Czech. For the Forsythia, we have, again, the recycled PLA is pretty good here, and that's really the only one that is coming up as above commercially acceptable at that point. So the polyamide PLA seems to be overall a good pot in our studies anyways. The polyamides are biodegradable polyester amides. Anybody who wants to jump in and correct me, just go ahead.
Most of those aren't biodegradable.
Oh, okay.
Polyamides aren't.
Okay.
They have shown that there's a few types that are, but
okay.
They're quite expensive.
Okay. Okay, great. Because that's sort of what I go on to here. The PEs are being used a lot in biomedical applications, which explains if they're expensive. So the polyamides that you were using were not necessarily things that are okay. These things probably are expensive. They've been optimized for their properties in terms of hydraulic or enzymatic degradation. So the polylactic acid, the PLA part of this, that was used in this study is a thermoplastic aliphatic. Does anybody remember what that is? Okay, so organic chemistry. Organic chemistry. Right. Oh, good. Okay. Well.
There's no double bonds with the aliphatic.
Okay. There's aromatic and non-aromatic. So this is the non-aromatic in your organic chemistry class. Polyesters produced from renewable resources such as cornstarch or fermentation, through fermentation. PLA is the most widely used bio-based and biodegradable polyesters. Is that correct?
Yes.
Okay.
Biodegradable in industrial composting.
Okay, great. I'm glad to know that I got something right. Why are we using plastic containers? I guess we've sort of touched on this a bit, but not really at this conference. They're moldable, obviously, into all the different kinds of shapes and things that we want. They're strong, they're lightweight, they stand up in production and shipping, which is probably the hardest point on the container. And that's another thing that we haven't looked at yet, is how they are going to stand up in that process. That's where the fiber pots fell down before, when we were using fiber pots, was they do not stand up through the shipping process. And of course, we have a very tough environment. The plastic containers are not perfect. Of course, these black plastic pots cause heat buildup in the pot, which can cause a loss of roots. Particularly this occurs on the southwest side of the pot. And then of course the root circling because of the smooth walls of the container. Most people don't realize that it is the smooth walls of the container, not just the fact that it is a circle that creates the circling roots. And then just all the things that they have to stand up through, all the mechanization that they will go through, even in the potting line, the filling process, the watering, the overwatering, and then the high temperatures, the low temperatures, the wind, the flying debris that's going around, the dirt, and more dirt at the nursery. As I mentioned, heavy irrigation, mechanical stress, chemical spraying with a variety of different toxic kinds of materials, fertilizers, etc., etc. So that's why we're using those plastic materials, and to enter into something that's going to be biodegradable in this environment is not an easy thing that is done. So again, this project is definitely fitting in with the 3 goals of sustainability. It definitely fits in with the broader goal of sustainable landscape management, which is what we are all about. And like I said, we'll take a short break.